Okay, this is question number 8 of Module 10 Practice Problems. And it asks us, it's a little bit different from the other ones we've done on video here. It asks us essentially what the molality is of a solution. Molality is another way of determining concentration, symbolized by a small m, not a big M. That's why we don't want to use little m's for moles, because then we'll get confused. Molality is a small m. And to figure that out with the information that we have to use this formula. This is change in temperature. It already told us what change. Delta, that's a Greek symbol delta, which just means change. Change of temperature is 18 degrees. We want to lower it 18 degrees. So I'm just going to put that over here. Change of temperature equals minus 18 degrees Celsius. What other information do they give us? We're going to add sodium chloride. Sodium chloride it can be split into 2 ions. That's what I represents, is how many ions this compound can split into. It is an ionic compound, so it can split into 2 ions. So I, in this case, is going to be 2, because it's sodium chloride. It turns into ions of sodium and ions of chloride. And then what is the molality of the solution? But we've also been given what Kf is. Kf, which is just a constant. It's always true for a particular solvent. In this case, the solvent is water, which we'll use most of the time. And that is 1.86 degrees Celsius over molality. Now, you might not be clear on what molality is. Molality equals moles over, not liters anymore, kilograms of solvent. I'm just going to put solvent there because it's not kilograms of solution, it's kilograms of solvent. The moles is still moles of solute. So that's what molality is. So we've got enough information to work this problem, but we've got to change this formula a little bit so that molality is, since that's the thing we're looking for, that is on one side of the equation. So essentially, if we divide both sides by everything else on this side of the equation, we can make ourselves in other words, if I divide this side of the equation by negative I and by Kf, then, and divide this side by the same thing, negative I and Kf, multiplied by Kf, then I can cross the negative i's, cross the Kf's, so I'm left with molality equals change of temperature divided by negative amount of ions, I, and that freezing point constant, which they gave us. So, just to write this out again with a different color, because I like to keep it pretty here. So molality, once again, is change of temperature divided by negative I, and multiply that on the bottom by Kf. We've got all that information there. So change of temperature we decided was minus 18. So that's the same thing as saying minus 18. And we decided that I is 2. So negative I would be negative 2. I could put that in parentheses so I don't get confused. Multiplied by Kf, which is, this doesn't have a unit, this does have a unit, this is degrees Celsius. The Kf is going to be 1.86 degrees Celsius over molality. And that we can work out to get our answer. You might notice that, let's get a red in here, that this degrees Celsius can be eliminated because there's a degree Celsius on the bottom. So we're going to be left with 1 over molality, little m, which is the same thing as saying molality. 1 over something essentially brings it back to just being itself, if that makes sense. Hopefully it does. But I'll do the calculation. I did the calculation, essentially just to make it clear, I multiplied those two items on the bottom, -2 times 1.86, keeping the 1 over molals, and that gave us a minus 3.72 1 over molals. And then I took that negative 18 divided by negative 3.72. Since 18 was only two significant figures, I had to reduce this long number to 4.8. And I know that 1 over molals is the same as saying molals, or molality. And that ends up being our answer, because the question asked what are the molals of this, what is basically the concentration or the molality of adding this salt to a solution of water to drop the temperature. So I will put a square around that, call that my answer.